Dear students, in the last class we end up the one topic, some basic concept of chemistry. In this video, let's start with the new topic, states of matter. Myself Rama, SDM View College, Honour. This states of matter belongs to your physical chemistry topic part. Under this topic, we discussed about the gaseous state. Before that, we should know some basic idea about the matter. You already well known about what is matter and the definition of matter, classifications of matter and all things. This topic belongs to physical chemistry. Therefore, we have studied about the physical classifications of the matter. Matters are physically classified into three types: solid, liquid, gaseous. Out of these three, the gaseous states of matter is studied under this topic in the solids in your second year studies. This states of matter involves some basic idea about the forces between the molecules. Then what type of force, and in case of study of the gaseous part, the gases are mainly exist in the form of a molecule. Therefore, the study of forces between the molecule is very important. There is no need of study of atomic state. Therefore, the first very basic part of this topic is intermolecular force. Intermolecular force. Then what is the meaning of this intermolecular force? And don't discuss about the classifications of matter and matter, because it is irritate you. I think that part we are already studied many times in the first topic, correct? Okay, directly and jump to the intermolecular force. The intermolecular force, inter inside the molecule is molecule, between the molecule, okay, inner side of the gaseous. What type of molecular forces observed? There are two types of force. One is attractive force, another one is repulsive force. In this case, intermolecular state forces, mainly we studied about the attractive force. Okay, there are two types of force, but we studied about only attraction or attractive force. The force involves only attraction, or study of the force that involves only attraction is considered one different part, or that was explained by van der Waals. Therefore, the only study of force of attraction is known as van der Waals force. Van der Waals force. What is this van der Waals force? Now, van der Waals force is nothing but force of attraction. Okay, force of attraction is known as van der Waals force. This van der Waals force is further classified based on the nature of molecule. Based on nature of the molecule that present in the matter is based on nature of the molecule that present in the matter. Van der Waals force is further classified into three types. Okay, it is completely based on the nature of the molecule. Then what are the three types of forces, or force of attractions, or force van der Waals forces? There are three types of van der Waals forces based on the nature of the molecule. Let us start with the types of van der Waals forces based on nature of the molecule. Okay, types of van der Waals force. First one is dispersion. First one is dispersion force. Second one is dipole interaction or dipole force. Third one is dipole induced dipole force. Now, on what basis these three types of forces observed? Based on nature of the molecule. Before the study of these types of forces, let us understand the concept of the molecules. Okay, we know the several type of molecules. Anybody just recall in your mind the different types of the molecule? Okay, so molecules, I am giving a few example. Hydrogen molecule, okay, oxygen molecule, next chlorine molecule, next and consider carbon dioxide molecule, okay, carbon dioxide molecule, water molecule, hydrochloric acid, hydrogen bromide, okay, ammonia, and there are several types of molecules we come across in your chemistry, correct? And consider few molecule. In this molecule, what are the different things we observed? When we observe the hydrogen and oxygen, chlorine, like these type of molecules, these are made up of only one type of element, correct? Only one type of elements are there. Hydrogen molecule is made up of hydrogen atom. Oxygen molecule is made up of oxygen atom. Chlorine is made up of chlorine atom. These are called diatomic. These are all present in or exist in diatomic state, correct? These are exist in diatomic state. These are known as diatomic molecules. These are diatomic molecules. And in this case, carbon and oxygen. The molecule is made up of carbon and oxygen atoms. Therefore, it is different or heterogeneous combination is observed. Next, in case of water, it is made up of hydrogen and oxygen. In hydrochloric acid, hydrogen and chlorine, ammonia, nitrogen and hydrogen. So, basically, when we are generally observed these molecule, we saw two different things in the molecule. In chemically or in physically, these molecules, the physically we saw this type of diatomic state and polyatomic states are observed. Chemically also it behaves in different way. And when we going through a study of the polarity of the molecule, then also we saw different kinds. Then what is the polarity? Polarity is poles. You already know about the poles. Positive and negative charge. When we consider the core of these molecules, how the charge is distributed? The charge distributed based on the electronic arrangement, correct? So based on electronic arrangement or the distribution of charge, we measure the polarity, and it is called as dipole. Suppose it has two poles, then we call it as a dipole. These all the polarity is measured in terms of magnetic under the magnetic property. Okay, polarity belongs to magnetic property. Then what are the different types of polarity observed in this molecule? The hydrogen molecule, the positive and negative charges completely overlap in the hydrogen molecule. Therefore, it behaves as a neutral. Therefore, it is non-polar. Suppose if we consider hydrogen molecule, okay, the hydrogen molecule behaves like a non-polar or it behaves like a neutral because the magnitude of positive is completely overlapped on the magnitude of the negative charge. The magnitudes cancel each other, therefore the magnitude of positive and negative charges cancelled, therefore hydrogen becomes the non-polar molecule. Oxygen, same thing happens, it is non-polar. Chlorine is again non-polar. What it indicates, it clears that all the diatomic molecules, are non-polar. All the diatomic molecules are non-polar. If you consider bromine, then again it is a non-polar. If you consider iodine, then it is a non-polar. And all the noble gases, helium, neon, argon, krypton, xenon, so these all the atoms are non-polar atoms. These are non-polar molecules. Now, when we move to the carbon dioxide, in carbon dioxide, carbon present in the center and oxygen present adjacent to this carbon. Dipole moment of these cancels each other. Remember that it is not polyatomic, not diatomic, it is polyatomic. In this case also, we observe the non-polarity because of this dipole moment. Now, what is dipole moment? Dipole moment is just the difference in the electronegativity causes the dipole moment. Okay, what is electronegativity? That part you are studied in the classification of the elements and chemical in the chemical bonding. You will discuss. You will learn about all these things. Okay, dipole moment and all this. After the completion of that topic, you get more idea about the dipole moment. The dipole moment, and just give the idea about the dipole moment. When you compare the carbon and oxygen, oxygen is more electronegative. Therefore, the electronegativity moves towards oxygen. Electronegativity, due to electronegativity, electron charge or distribution of electrons towards oxygen. Here moves towards oxygen. These two cancelled because of the magnitude, okay, opposite direction. Because of that, cancels each other. It behaves like a non-polar. Okay, dipole moment becomes zero. Therefore, it becomes a non-polar. So these molecules belongs to non-polar type. And now, water. What happened in case of the water? Yes, oxygens are present at the center, but according to the shape of the molecule of water, it's a bell shape. Due to dipole moment is oxygen is small electronegative, tries to take the electron towards and dipole moment is resultant dipole moment is upward. Has some dipole. When it has some dipole, now it become polar. Okay, it is a polar molecule. Similarly, hydrogen and chlorine. What happened in case of hydrogen? Hydrogen and the chlorine molecule. Hydrogen, in case of hydrogen and chlorine molecule, the electron density of the hydrogen slightly moves towards the chlorine because of more electronegativity of chlorine. When chlorine takes electron, ನೋಡಿ ಯಾವುದೇ ಒಂದು ಎಲಿಮೆಂಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಳ್ತದೆ, ಓಕೆ, ಸೊ ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ತನ್ನ ಹತ್ರ ಎಳ್ಕೊಳ್ತದೆ ಟವರ್ಡ್ಸ್. ಯಾವುದು ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇದೆ ಆ ಕಡೆಗೆ ಏನಾಗ್ತದೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ ಆಗ್ತದೆ. ಸೊ ಹೈಡ್ರೋಜನ್ ಇಂದ ಕ್ಲೋರಿನ್ ಕಡೆಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ ಆಗಿದೆ, ಕರೆಕ್ಟ್. ಸೊ chlorine get partial negative charge. When hydrogen combined with the chlorine, hydrogen loses its electron. What happened when it loses its electron? It present only one electron. In case of hydrogen, there is only one electron, correct? That electron moves towards chlorine, therefore it gets partial positive charge. What happened in this case? Yes, dipolarity observed. Polarity is observed. Okay, one side positive charge, one side negative charge, or one side more electron density. Which side the electron density is more, that part get negative and on the other part become positive. Polarity is observed. Poles is observed. Polarity happen. As a dipole. Sorry, magnetic momentum. Some magnetic moment is observed. So due to that it is a polar. So again it is a polar. Again it is a polar. So these are the polar molecules. These are polar molecules. Okay. According to the polarity of the molecule, few molecule become or belongs to the non-polar type, and few molecule belongs to polar type. Due to difference in the polarity of the molecule, when these molecules come contact together, what type of forces observed between these molecules? The study of the forces between these molecules is called intermolecular force. What is intermolecular force? It is the study of forces between the molecule. That one is now called as intermolecular force, or simply force exists between the molecule. Okay, force exists between the molecules is called intermolecular force. If the force is only attractive, then it is termed as van der Waals force. Get the idea? Okay. Only force of attraction between the molecule is considered as or termed as van der Waals force. In the molecule there are different nature or different types. According to the polarity of the molecule, there are two types. Few molecule belongs to non-polar, few belongs to polar. Due to difference in their polarity, when these molecules come contact each other, we observed three different types of forces between these molecules. The force of attraction between these molecules is classified into three types. Okay. ಯಾವುದು ಓನ್ಲಿ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇದೆ, ಅದಕ್ಕೆ ವಾನ್ ಡೆರ್ ವಾಲ್ಸ್ ಫೋರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ವಾನ್ ಡೆರ್ ವಾಲ್ಸ್ ಫೋರ್ಸಸ್ಸಲ್ಲಿ ತ್ರೀ ಕೆಟಗರಿನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೇವೆ, ತ್ರೀ ಟೈಪ್ಸ್. ಈ ತ್ರೀ ಟೈಪ್ಸ್ ಯಾಕೆ? ಬಿಕಾಸ್ ಆಫ್ ದ ಪೊಲಾರಿಟಿ ಯಾಕೆ ಬರುತ್ತದೆ? ಬಿಕಾಸ್ ಆಫ್ ಡಿಫ್ರೆನ್ಸ್ ಇನ್ ದ ಇಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ. ಓಕೆ, ಒಂದು ಕಡೆಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ, ಇನ್ನೊಂದು ಕಡೆಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಕಡಿಮೆ. ಸೊ ಈ ಥರ ಯಾವಾಗ ಮೊಲೆಕ್ಯೂಲ್ಸಲ್ಲಿ ಆಗ್ತದೆ ಆವಾಗ ಅದು ಪೋಲಾರ್ ಮೊಲೆಕ್ಯೂಲ್ ಆಗ್ತದೆ. ಸೊ ಇನ್ನೊಂದು ಕೇಸಸ್ಸಲ್ಲಿ ಎರಡು ಕ್ಯಾನ್ಸಲ್ ಆದಾಗ ಅದು ನಾನ್ ಪೋಲಾರ್ ಮೊಲೆಕ್ಯೂಲು ಮತ್ತು ಪೋಲಾರ್ ಮೊಲೆಕ್ಯೂಲು ಯಾವಾಗ ಹತ್ರ ಬರ್ತದೆ, ಸೊ ಆವಾಗ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೇವೆ. ಸೊ ಆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸಸ್ ದೀಸ್ dispersion force, dipole and dipole induced dipole forces. Okay, so these are the three different types of forces we observed under van der Waals forces. Let us discuss about the types of these van der Waals forces. Okay, first one is dispersion. What is dispersion force, and when we observe the dispersion force? Dispersion force is also known as London force. Okay, it is also known as London force. Dispersion, the word itself says disperse. Okay, initial place, charge has some place or core. In the core we observe the charge. When it come contact with another accidentally, then the charge may slip one place to another. That cause is considered as a dispersion. ಸೊ ಅದನ್ನು ಏನಕ್ಕೆ ಕರಿತೇವೆ? ಡಿಸ್ಪರ್ಷನ್. ಒಂದು ಚಾರ್ಜ್ ಒಂದು ಕಡೆ ಜಸ್ಟ್ ಸ್ಲಿಪ್ ಆಗಿದ್ರೆ ಅದು ಡಿಸ್ಪರ್ಷನ್. ಸೊ ವರ್ಡೇ ಹೇಳ್ತದೆ ವಾಟ್ ಈಸ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸ್. ಓಕೆ, that was introduced by London as the name of the scientist. Therefore it is called London force. This dispersion force is observed between the non-polar molecule. Okay, the force of attraction, why I am using attraction? Because we studied the type of only attraction forces. There is no repulsion, there is no study of repulsion. There is a presence of repulsion, although we don't study the dispersion force. Okay, we discuss about only force of attraction. Force of attraction between the non-polar molecule, non-polar molecules, okay, in the non-polar molecule is called dispersion force. Now, how this dispersion force is observed? First, try to give the example of non-polar hydrogen, oxygen, chlorine, bromine, iodine, all diatomic molecule and as well as noble gases. And consider chlorine, Cl2, chlorine molecule. It is a non-polar molecule between the chlorine and chlorine molecule. Okay, chlorine and chlorine molecule. One chlorine molecule and another chlorine molecule. When we go inside the depth of this molecule, chlorine charge of chlorine atom or completely overlap one another. Because of that, there is a negative charge and there is a positive charge, cancels each other, therefore it behaves like a non-polar. It is a non-polar molecule. Accidentally, in case of a gaseous state, during the movement of the gases, one chlorine molecule come near to the another chlorine molecule. There is a process of positive negative charge inside the chlorine. Accidentally, these two molecules combined or hit together, then there is a possibility, okay, there is a possibility of just slip of one charge, any charge. Okay, just imagine in this chlorine, when these two molecules hit together, in one chlorine molecule, positive moves towards the chlorine molecule, negative away from the chlorine. Because of the sliding or dispersion of the charge in one molecule, that causes the dispersion of the charge in the another molecule. How this dispersion takes place in another molecule? When positive charge moves towards this one, then negative charge of this chlorine moves towards this chlorine and positive moves away. Because of positive repulsion and positive negative attraction, the negative charge of this chlorine moves towards this chlorine. So now we observe force of attraction between these two. Positive and negative charges attract together. So these two causes the force of attraction. Eventually these molecules may combine agbidabodu, or after few minutes it goes away. Okay, so ಬೇಕಾದದ್ದು ದೂರ ಸರ್ಕೋಬಹುದು. ಆಮೇಲೆ ಜಸ್ಟ್ ಒಂದು ಟಚ್ ಆದಾಗ or ಹಿಟ್ ಆದಾಗ ಅದರ ಪಾಸಿಟಿವ್ ಇದರ ನೆಗೆಟಿವ್ ಅಟ್ರಾಕ್ಟ್ ಆಗಿ, ಸೊ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಜನರೇಟ್. So that force of attraction is known as the dispersion force. Therefore we use the word dispersion of charge. Okay, next, what are the characteristic of dispersion force? Is it permanent force? No, it is not a permanent force, and it's a weakest van der Waals force. Okay, it is the weakest van der Waals force. It is not permanent, it's the weakest van der Waals force. Now give us few example of dispersion force that's shown by the molecule. The molecules like oxygen, nitrogen, chlorine, hydrogen, helium, the next is bromine, iodine, sulfur. So these gaseous molecules shows the dispersion forces. Okay, I think it's clear. Correct. Okay, what is dispersion force? The force of attraction between the non-polar molecules. Example, these molecules shows dispersion force. Next, move on to the second type of van der Waals force. What is the second type of van der Waals force? Dipole force. I think now you are able. I think most of you are guess what is the dipole force. It is possible, correct? What is dipole force? The word itself says dipole, two poles. Molecules which has two poles, Molecule which has two poles means two pole molecule is considered a pole. When we observe the poles, then the molecule is considered as polar molecule. Correct? The forces or force of attraction between the polar molecule is considered or known as dipole forces. Force of attraction, force of attraction between two polar molecules. Okay, force of attraction between two polar molecules is called dipole interaction or dipole force. I'm considering a few examples. Okay, here we should consider polar molecule. Okay, I'm considering the example of hydrochloric acid, hydrogen and chlorine. What happened in case of hydrogen and chlorine? Hydrogen is smaller, chlorine is bigger molecule. Okay, the positive charge is present on the hydrogen and the negative charge is moved toward the chlorine already because of the more negativity of chlorine. The electron density moves towards the chlorine and electron density goes away from the hydrogen. Because of that, hydrogen get partial positive charge. So here we observe partial positive, here we observe partial negative. So it can be shown in different ways. So it's a actual picture of hydrochloric acid or a molecule, hydrogen chloride molecule. In these cases, what happens when two hydrogen chlorine molecule come near each other? One hydrogen chlorine next, so that it has already has a partial positive and partial negative charge. During the movement of the hydrogen chlorine, because of these are gases always present in a state of movement or fluidity is observed, flowing nature is observed. So during the movement of the molecules of hydrogen chlorine, suppose these two molecules come near to each other, the partial negative charge of the chlorine attract the partial positive charge of the another chlorine molecule. Correct? This negative charge attract the positive charge. This force of attraction is nothing but dipole interaction. Why it is dipole? There are two poles. Correct? It is a dipole molecule. Polar, it is dipole molecule. It is a dipole molecule. The interaction between the two dipole molecule is called as the dipole force or dipole interaction. So in definition, force of attraction between the two polar molecules is known as dipole interaction. Okay. Examples: forces between the polar molecule: hydrogen chlorine, hydrogen bromide, hydrogen chloride, hydrogen bromide, hydrogen fluoride, hydrogen iodide, between the water molecule, water, ammonia, etc. Okay, so these are the example of dipole forces. We observe the another very important concept under these dipole forces. It is called special case of dipole interaction. The special cases of dipole interaction and the dipole induced dipole, that part will be discussed in the next video. Okay, because of the time interval or the limited time, I'm stop the video in this in this part. Okay, in the next video we will discuss about the special case of dipole interaction and dipole induced dipole force. So these are the first part of this topic. Okay, thank you for watching.